For my behavioral analysis video project, I am focusing on preening behavior in Canada geese, Branta canadensis. This behavior was observed in my original field videos of geese at a pond in Williamsburg, Virginia. I chose preening because it was clear enough to describe in an ethogram and because it can be analyzed using all four of Tinbergen's levels of analysis. In this clip, the goose turns its head toward its own body and uses its bill to manipulate the feathers. The bill contacts the flank, back, breast, or side feathers, and the behavior lasts for more than a quick touch. So I classified it as a state behavior rather than a single event. I'm describing only the visible action here, not assigning motive. The goose bends its neck, brings the bill to the plumage, and works through the feathers before returning to a more upright posture. In Module 1, we learned that Tinbergen's 4 levels of analysis help explain how and why animals behave the way they do. Causation and development are approximate explanations because they focus on mechanisms within the animal's lifetime. Evolution and function are ultimate explanations because they focus on evolutionary history and adaptive value. All 4 explanations can be true at the same time. They are different levels of analysis, not competing answers. My causation hypothesis is that preening is triggered by immediate sensory or psychological cues, such as feather wetness, feather misalignment, irritation, or the need to spread preen gland secretions. This fits the causation level because it focuses on the real-time mechanism that causes the behavior. Rowe in 1983 found that Canada geese and mallards show organized preening patterns, and Gurdu and colleagues in 2010 found that mallards without access to preen gland secretions had poorer plumage condition and retained more water. This supports the idea that feather conditioning can be closely connected to preening. My development hypothesis is that preening becomes organized as young geese mature, grow functional feathers, and gain experience using aquatic and shoreline habitats. This fits the developmental level because it asks how the behavior develops during the individual's life or ontogeny. As a goose develops from brownie young into a feathered waterfowl, feather maintenance becomes increasingly important. Studies such as Gurdu in 2010 and Moyer in 2003 support the importance of preen oil and feather condition, which helps explain why the behavior would become important as plumage develops. My evolution hypothesis is that preening is an inherited species typical avian behavior that has persisted across waterfowl because feathers are essential for insulation, waterproofing, and movement in aquatic environments. Rowe's 1983 comparison of Canada geese and mallards support this because both species showed organized preening. My function hypothesis is that preening increases fitness by maintaining feather alignment, spreading oils, supporting waterproofing, and reducing parasites or microbes. Moyer in 2003 and Waite in 2012 both support links between preening or preen oil and ectoparasite control. However, preening also has costs. Redpath in 1988 showed that preening can be part of a vigilant trade-off, meaning time spent preening is time not spent scanning for threats. Overall, this behavior connects strongly to Module 1 because Tinbergen's framework lets me explain one behavior from 4 angles. At the causation level, preening may be triggered by immediate feather or body cues. At the development level, it becomes organized as the bird matures. At the evolution level, it reflects an inherited avian behavior. At the function level, it has adaptive value because it helps maintain feathers, but it also has costs. This connects to the cost-benefit approach from class. A behavior can be adaptive when its fitness benefits outweigh its costs. So even though preening looks simple, it is a useful example of how animal behavior can be explained scientifically. And here are my references.